Hello everyone, welcome to the last lab video for the software design course, and today we'll be talking about the template design pattern. Alright, so let's establish the design context again. So we're going to try to model different board games, and we want to play these different board games. Now, we don't want to specify for each board game how this game should be played each and every single time, since this will lead to a lot of duplicated code. Instead, what we want to do is we want to have one template method, which is what the design pattern is named after, one template method that calls smaller methods that are specific to each board game. So we will have one large method that calls multiple smaller methods, and only those smaller methods need to be implemented in each board game, whereas the larger method will stay the same for all of them. So if you look at how this works in UML, we can see that we have an abstract class board game with two implementing classes, Ludo and Chess. Now, these all have the methods setup game, pick starting player, start playing, and end playing. But as you can see, the board game also has one method called play. And this play method is our template method. This play method will call setup game, pick starting player, start playing, and end playing in order. So we only need to implement those four methods in Ludo and Chess, instead of having to also implement the entire play method each and every time for each board game. So we have one method template, and the implementing classes, so Ludo and Chess, only have to define the smaller parts of this template and not the entire template each and every time. Alright, so now that we have seen how this looks in UML, let's go over to IntelliJ and implement this in Java. Alright, here we are in IntelliJ. So I've set up the classes that we just saw in the UML diagram, so board game, chess, and Ludo. However, I haven't implemented anything in any of these yet, so we'll be doing that together. So let's start by going to board game. And as we saw in our UML, we need four abstract methods, which we'll define first. So the first abstract method that we need to define is setup game. So this would be placing down the pieces, placing down the board, etc. Then we have another method called pick starting player. So this decides which player will begin the game. Then we have another method called start playing. So this is when the first player will take its first turn. And then we have the last abstract method, which is end playing. So this could be like someone has won, and then we put everything back into the box. All right, now we also need to define our template method, and we do this by making another method. However, this one is not abstract, so this one will be implemented by board game itself. So this is the play method. This play method will call each of these abstract methods that we just defined. So it will first call setup game, then it will call pick starting player, then it will call start playing, and then end playing. So now every time we want to play a board game, no matter what board game it is, we simply have to call the play method. And we don't have to implement this play method into each of our specific board game classes, like Ludo and Chess. We already have to define this here. So the only thing we need to do in these implementing classes is implementing the setup game, pick starting player, start playing, and end playing methods. So let's start by doing this for Ludo, and then after that we'll do this for Chess. So in our Ludo class, we first want to make it extend board game, since it is a board game. And then we want to implement the methods that we need to, like we just defined. All right. So these are the methods. For this example, we'll just be printing messages for these methods. So when we set up the game, we want to say setting up Ludo. Then for the starting player, picking starting the player, we'll just say picking a starting player for Ludo. And then we can do start playing. So player 1 rolls the first die. And then for end ends playing will have a message like player 1 has won the game. Alright, so these are our methods. And these will simply print some messages to illustrate the example. Now let's do the same thing for chess. So we go over to chess, and chess is also a board game. So we'll make it extend that. Then we again define these methods. So for setup game, we'll also print a message like setting up chess. And we'll pick the starting player. So in chess, the player with the white pieces always starts. So the white player can start, and then for start playing, we say the white player makes their first move, and then for end playing, we can say the black player has won. Alright, so now we have implemented the smaller components for each of the board games. However, we don't have to implement display methods for each of the board games. So let's see how that works when we try to play each of these games. So let's first do Ludo. So we'll create a new Ludo class and we call play upon it. And let's also do this for chess. So chess.play. So we'll now play a game of Ludo and play a game of chess. So when we run our code, what we can see, alright, so the first 4 lines are for Ludo. So we have setting up Ludo, picking starting player, player 1 falls the first time, and player 1 has won the game, which are the messages we've implemented over here. And then we have the same thing for chess, setting up chess, player can start, make the first move, and then the player has won, which are the messages we have implemented over here. So as you can see, we have now implemented a play method that can be used by all board games. And the board games don't need to define the play method themselves. They only need to specify the smaller parts of their game. So they only have to specify how the game should be set up, which player should start the game, how the game should be started, and how the game should be ended. They don't have to define each and every time how the play method should be implemented, since that is something the board game already has done. And that is how the template design pattern works in Java. So hopefully you found this useful. This was the last lab video for this course, so good job on going through all of them, and good luck working on your project.